Today we're going to talk about polar equations. So you've been working on converting coordinates, going from polar to rectangular coordinates, or the other way, rectangular to polar coordinates. Today you're going to convert equations. But what's nice about this is that we're going to be using the same relationships that we did before. So make sure you have all four of these written down in front of you. So a polar equation is going to be in terms of r and theta instead of x and y. So one example would be something like this, r equals 2. So if we want to convert that into rectangular form, we have to get rid of this r and replace it with x's and y's. And lucky for us, we know that r is equal to radical x squared plus y squared. So we can just substitute. Now if we square both sides, we get x squared plus y squared equals 4, which is the equation of a circle that has a radius of 2, which kind of makes sense if you look at this original statement here, r equals 2. So this is referring to a circle with a radius of 2. Now another type of equation may look like this. Let's say they give you theta equals pi over 3. So we're given a theta, we need to replace that. We only want x's and y's. So we do know that tan theta equals y over x. So we can take the tangent of both sides, whoops, didn't want that. Tangent of both sides will have tangent of pi over 3. And tan theta is y over x, so again, just substituting. And tan of pi over 3, that's the tangent of 60, which is just radical 3. And if we cross multiply, we get y equals radical 3x. And you'll notice that this is a linear equation that has a slope of radical 3 and a y-intercept of 0. So this line, here are our axes, it's a positive slope, goes through the origin, but this angle right here is going to be 60 degrees. So the way we represent a line using a polar equation would be theta equals the angle made with the x-axis. Okay, we're going to look at two more examples like this. And we'll start with something like this, r equals secant theta. Now there are a number of ways of going about this. One way would be to say that this is really 1 over cos theta. So we would get r cos theta equals 1 if we cross multiply. Now we know that r cos theta is equal to x, so we get x equals 1. And we've done it. We went from polar, which is in terms of r and theta, to rectangular, which is in terms of x or y. A different approach to the same problem could look like this. We could have r equals secant theta. We know that r is radical x squared plus y squared. And we know that secant is r over x. So now, again, we've got over x. R is also radical x squared plus y squared. If we cross multiply this, we're going to get x radical, and these two would cancel, and we'd be left with x equals 1. So you do whatever you're more comfortable with. We're going to do one more. Let's have r equals 5 cos theta, because sometimes it's not always obvious what to do. Now here, we know that r cos theta is equal to x, so it would be really nice if we could just kind of stick an r in there, which we can do as long as we do the same thing to the other side, so we'd have r squared. Now r squared is equal to x squared plus y squared. We've got 5 on the right, and cos theta is just equal to x. So we've gone from from polar in terms of r and theta to rectangular. We've got our x's, our y's, and I'm just going to bring that over, and we're done with that. So just a few examples of going in the opposite direction from rectangular to polar. Let's say you had a circle, like x squared plus y squared equals 100. Well, we know that x squared plus y squared is equal to r squared. So r squared equals 100, which means r equals 10. And we don't acknowledge the negative because we're talking about a radius, which should be positive. So that's it. We went from rectangular in terms of x and y to polar in terms of r and theta. Okay, one more like this. What if we had a line like y equals, let's go with 100 again. So y we know is r sine theta. So notice we've gone from rectangular already to polar, but we can solve for r here. We can divide both sides by sine. This is gone. We've got r equals, and instead of 1 over sine theta, we could write that, but we could also write that as 100 cosecant theta. So our summary is pretty much the same as it was with polar coordinates. Now we're converting polar equations and rectangular equations, but we use the same relationships.